generator is basically the same like the alternator that we studied some chapters ago. The alternator, if you remember, is an equipment that in the input have mechanical power and in the output produce electricity. In this particular case, the alternator produces DC current. The generator is basically a big alternator. The mechanical power is produced for one engine, diesel or gasoline, and the back end produces electricity. Remember that the alternator internally in the first stage produces AC power, and after that the AC power is rectified by means of the bridge of diodes and is converted into DC power. The generators are classified according where is produced the electricity and where is produced the excitation. The generators are classified in armature type and alternator type. In the armature type is a generator that have a self-excitation, no brushes. In the alternator type, it's exactly the same like the previous alternator. The generator have brushes and the excitation is produced on the rotor. Okay, in the alternator type, the excitation is produced in the rotor and the AC power is produced on the stator. In armature type, the excitation is produced on the stator and the AC power is produced on the rotor. Additional to the rotor and the stator, the back end have two important components. One of these is the control box. The control box is where the DC elements, the DC harness of the engine is concentrated. In the control box, this is the control box. The control box have the switches, the start, the preheat or ignition, the stop. Those are normally open push buttons, normally open buttons. The fuses for ignition and the fuse for start, and the hour meter. Internally in the control box, there are relays: a start relay, run relay, and a stop relay. Start, run, and stop relay. And the connection for the harness of the engine. In the next episode, we are going to do this harness, the harness of the engine, included the gauge, oil pressure gauge, temperature gauge, fuel gauge, and hour meter. We are going to do the harness completely in the next episode. The AC output panel board is basically this equipment. It's the element where the AC produces for the back end of the generator. The hot, neutral, and ground enter in this panel board, and according with the configuration of the panel board, the generator can be configured for American power, European power, single phase, double phase, or three phase, depending how is configured the panel. In what cases you need check the frequency. Normally, the frequency is modified if the generator have mechanical problems, like I explained previously in the previous episode. Frequency is directly related with low RPMs. And in other words, frequency is a mechanical problem on the generator. It's a problem on the engine. It's not a problem on the back end, on the electrical side. The majority of the marine technicians, when they have codes related with low or high frequency, they try to fix the frequency here in the back end. That's not good, because low frequency normally is a problem related with the engine, low RPMs. The first step is go into the pedestal and check with the voltmeter, the frequency of the pedestal on the breaker of the pedestal, or directly on the outlet of the pedestal in between hot and neutral. Any hot and neutral, and verify if the voltage is 120 and the frequency is 60 Hz. In this particular scenario in America, 60 Hz, 120 volts in each phase. Okay, suppose that the frequency at the pedestal is good. It's 60 Hz, it's 120 volts, 119, In other words, that frequency is perfect. And now I am going to check in the generator. The procedure to check the frequency on the generator is with the generator running. Suppose that the frequency here is not 60 Hz, it's 57, 56. Oh, the frequency is too low. What is the procedure to calibrate the frequency? Once again, I continue with the generator running. With the generator running, my frequency right now is 57, it's an example. I need adjust, this is the fuel injection pump, this is a diesel engine, diesel generator. At the fuel injection pump, at the governor, we have 2 bolts. 1 bolt for idle, like this one. This is other fuel injection pump for other generator. And I have 2 bolts. 1 bolt to adjust idle, and other bolt to adjust wide open throttle. With a safety wire in between both of them. Why? Because remember, the RPMs in the generator should be constant, no moving. For American Power, the RPMs should be 1800 RPMs. For European Power, the RPM should be 1500 RPMs. And the handle for the throttle should be fixed, no moving. How I can fix? With those bolts. Idle and wide open throttle, and I put the safety wire in between. Okay, in this moment my generator is running with 57 Hz. I cut this safety wire and I adjust the idle bolt until the frequency increase 58, 59, 60 Hz. And now with 60 Hz I go into the AC panel. I turn on the breaker again. Once again, breaker on, go to the AC panel, and I apply loads slowly. I start with the small loads and I finish in the heavy loads, air conditioned equipment. I apply the loads and I check that the frequency stayed in 60 Hz. Okay, in this particular case, if I have the manual, I need identify what is the position of the AC terminal block in the manual. This is the AC terminal block. The AC terminal block is located in the back end of the generator, like this. It's a block with 2, 4, 6, 8 terminals, in some cases 12 terminals. It's basically like this. In this terminal block, those cables are the cables coming from the generator, from the back end. And those are the cables coming out. Those are the cables coming out, hot, neutral, and ground. Hot, neutral, and ground. Those are the cables that goes into the AC panel. The back end here, and you disconnect the terminals and you organize the terminals according with the new position. And you put the new position that you needed. For example, in this moment, this generator is a European generator. I want to convert the generator into American generator. Okay, I move the terminals according with the new configuration, and now I tight properly. Not too much torque because this is a backlight. This is like a plastic. You verify with full load on the breaker on the panel. The frequency stays 60 Hz. My generator is converted.